Okay, so we are in Notes 2.6, note-taking with vocabulary. We're going to be talking about angles. And the definition of an angle that I'm going to be working with, this wouldn't be the official one, but the one that I'm going to work with is, it is the measure of space between two intersecting lines. So the way that looks is if I've got a line here, or this is more of a ray, but that's okay. I've got another one here. Let's call this E, F, G. The angle is going to be this space here. This is the angle. So it is the space in between two lines. So a vertex is going to be the corner point, or the point of intersection, right? So for our angle that we just drew, it's going to be point F. That's the vertex. The sides of the angle are going to be the two lines that make up the angle, the two intersecting lines. So for ours, that's this one here, that's FE, and this one here, FG. FE and FG. These would be the sides. So that's a side and a side. So the interior of the angle, this is pretty much the one we talk about. This is inside the angle. So if we were to draw another angle here, right, this would be the interior. And then this almost never comes up, but occasionally it's going to be the outside of the angle. This would be the exterior. That rarely comes up. 99% of the problems that you do are going to be interior angle problems. Then the measurement is that space. So if I've got a big space, this would be, like 89 degrees maybe. And then if I had a small space, right, this might be 30 degrees or something like that. But it's measured in degrees, so the measure of an angle is going to be a measurement in degrees. So that's some kind of basic definitions to kind of get us started thinking about this. Down here, we're going to talk about naming them. How do we name angles? And the principal way we do it is with three letters to say, okay, well, number 3 here, we could call that A, B, C. And make a little note here. Vertex is always in the middle. So A, B, C, we could just as easily call it C, B, A. But we would say C to B to A. That's the general idea there. So this, and then sometimes if there's only one angle at the vertex, you can also just call it angle B, kind of for short. So this one here, try and find the 3 names just as we just did for number 4. So if you pause the video, so if you paused your video and did this, you probably would have come up with, we'd start at F, go to G to H, right? That would be one angle, F, G, H. The other angle would be to go backwards and go H to G to F. So that would be H, G, F, always with the vertex in the middle. And then since there's only the one angle there, we could call this angle G. So occasionally you'll see this as well. You'll see it, we could call this JKL. We could call it LKJ. draw a better J. We could call it angle J. And then sometimes you'll see this little 1 there. What they're asking you to do is call this angle 1. And that would be the fourth way you could name that angle. I don't love that, but you'll see it from time to time, so I want you to recognize it. So let's try this next one. We could call this QRS. We could call it SRQ. We could call it angle Q or angle 8. All right, let's take a look at these other problems here. So they want you to name all the angles at that given vertex. And we can't really call this one angle M because there's 2 angle M's. So that's not going to work. We have to use the 3-letter method. So I'm going to say, well, I see one angle here from H to M to K, right? So we're going to call that angle HMK. I see another one, this one, from K to M to N. And that's going to be KMN. And then we have this big angle from H to M to N. HMN. With M always in the middle because that's our vertex. Take a minute and see if you can do number 8 the way we just did this. If you paused your video, you should have GJC, that one, GJC. You should have FJC, so the other side. So that's FJC. And then lastly, just erase that. Lastly, we should have this big one from G to J to F. G, J, F. That would be our third angle there. So moving on, we're going to skip this for now. We're going to skip that. And we're going to take a look at these. So we've got a couple different types of angles. You should have seen this before, just as a review though. An angle that measures less than 90 degrees, we call that an acute angle. Angle that measures exactly 90 degrees, we call that a right angle. Angle that is greater than 90 degrees, we call that an obtuse angle. And one that measures exactly 180, we call that a straight angle. So that's going to come up fairly frequently. So let's skip the angle addition postulate for a minute. We're going to come back to that. We're going to look at this protractor, some protractor practice. So this is how we measure angles. We usually measure these on a protractor. And you see these 2 sets of two sets of numbers. We got this one on the bottom here, right? We've got this set of numbers. And then we've got this other set of numbers along the top. So what do we do? So we're going to say that the top ones, and then we've got the bottom ones. So the ones on the, if we're measuring from the right-hand side, we're going to use the bottom numbers. And if we are on the left-hand side, we're going to use the top numbers. Right? So this first angle here, AOB. A, we're on the right-hand side, so that means we're going to use the bottom numbers. We start at 0, and we're going to go from A to O to B. So we're talking about this angle there, A to O, from A to O to B. Right? And so that gives us 10, 20, 30, and halfway in between 30 and 40. So this is going to be 35 degrees. Let's take a look at another one now. Let's look at one from the left. So let's look at FOE. Let's look at FOD, excuse me. So F is on the left-hand side, right? So we're going to be using the top numbers, and we're starting at 0, So I'm going from F to O to D, right? So we're thinking about that angle there. So I'm going to just count 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50, 60, and it's right on the money there. So that's going to be 70 degrees. So I want you to take a minute and I want you to do the rest of these problems here. And then stop when you get to BOE. And we'll relook at that one. Okay, so if you are at BOE, okay, so let's look at BOE. So we're talking about from B to O, which is our vertex for all of them, B to O to E. So how would I do that one, BOE? Well, if I looked at A, O, E, I'd say, well, that I know is at 150 degrees. And we're just going to be subtracting this bit here. I'm just going to subtract that 35 degrees from AOB. And we would get, let's see here, 150 minus 30 is 120. So minus 5 more is going to give us 115 degrees from B to O to E. Try and do BOC, COD, and EOB the same way we just did that. Okay, now lastly, let's go to the angle addition postulate. And the big idea with the angle addition postulate is that we can combine angles, combine two or more smaller angles to make a bigger angle. If, this is a big if, they share a common side. So I've got two angles, RSP and PST. So I've got these two angles, right? And they share this common side. They share this side SP, right? They both have SP in them. So what I'm saying is I can say, well, why don't I take this angle here, right? That would be RSP. And I can take this other angle here, that would be TSP, and we can add those together. So I can say angle RSP plus angle TSP. If I add those together, I'm going to get this big angle here, this one on the outside, this angle here, RST. That's the big idea. So let's look at a couple practice problems, and we're going to go to the last page. So again, I've got these smaller two smaller angles. I've got BLM, so angle BLM. And if I add it to this other small angle, KLB, angle KLB, it's going to equal the big angle, KLM. So I've got two smaller angles, BLM and KLB. And if I combine them together, I'll get the big angle, KLM. So now all we got to do is plug in what we know. So we know KLB is, oops, that's the purple one, KLB is 26. And we know BLM is 60. And we want to know what is KLM. What is the big one? So we're just going to leave that KLM. So now all we do is simplify. So 60 plus 26 is 86 degrees. So our final answer there is KLM is 86 degrees. Let's take a look at one more. Let's look at number 6 together. So we can say, okay, well, this small angle, EDW, plus this other angle, WDC. If I add those together, we're going to get the big angle, which is EDC. So now let's plug in what we know. We know EDC, that's the big one. EDC is 145 degrees. We know EDW, the blue one, is 61 degrees. And they said to find WDC. So we're going to just leave this WDC. So if I want WDC on its own, I'm going to subtract 61 on both sides. Right? 61 minus 61 cancels out. I'm left with WDC equals 145 minus 61. 145 minus 60 would be 84 degrees. And you should check your answer. I gave you all the answers here, so check your work here before you turn it in. Give these practice problems a shot. If you're struggling, try and get with me later. And that is notes 2.